So hello, good morning everyone. We are the group 1 and we are going to present all about the spectrophotometer. So let us know first what is a spectrophotometer. So ang spectrophotometer is an optical instrument that measures the intensity of light in relation to the wavelength. Minimeasure niya just about anything such as plastics, paper, liquid metal, and fabric. So being a color measurement device, it makes sure that yung color is consistent simula sa conception hanggang doon sa delivery. So as a part of the color control program, yung mga designers and brand owners, ginagamit nila tong spectrophotometer para ma-capture or ma-evaluate yung mga color and monitor color accuracy throughout production. So itong image ito yung pinaka-basic na typical na basic structure ng spectrophotometer. So, meron tayong most popular spectrophotometer. Ito yung 45 degrees, sphere and multi-angle spectrophotometers. So, next. So, dito man tayo sa parts of our spectrophotometer. So, ito yung pinaka-basic spectrophotometer instrument. So, meron tayong light source, adjustable aperture, ito siya. Yung monochromator, ito yung cuvette, sample, photoresistor, then itong output. So, ang light source, there are two light sources. First one is yung tungsten lamp, which generates visible light, and a deuterium or a hydrogen lamp, which generates UV light. So, ang deuterium lamp, nagigive siya ng wider and more intense light in UV region kaysa doon sa hydrogen lamp. So, the light from the light source is known as polychromatic or heterochromatic since it is composed of wide range of wavelengths. The polychromatic light is reflected back using a plane mirror which passes through an entrance slit, condensing lens and falls onto the monochromator. So, ang monochromator natin, nag-produce siya ng radiations. Ito yung nagpo-produce ng radiations of single wavelength. So, the monochromator disperses the light and the desired wavelength is focused on the exit slit using the wavelength selector. So, yung pangatlo is yung cuvette. Ito siya. Ito yung cuvette. Ayan. Tapos ito kanina yung light source. Tapos yung monochromator. So, yung cuvettes are optically transparent cells made of glass or silica or plastic or quartz. So, ito yung nilalagyan ng sample solution. So, they are based either upon by refraction by a prism or by diffraction by a grating. So, for visible region, yung prisms are made up of glass and for UV region, ginagamit nila is quartz or silica. So, next, yung photocell or photomultiplier tube or photoresistor. Ito yung photoelectric device which converts light energy into electrical energy then amplified, detected, and recorded. So, ito siya. Ito yung photoresistor. Yan. So, next is yung adjustable aperture. Ito naman yung adjustable aperture. Ito. Yan, adjust yan siya. So, an adjustable aperture, it directs light. It is a small hole that directs the specified wavelength to a part of the sample. So, for the sixth one is yung sample yung nilalagay doon sa cuvette natin. So, it is a solution user desires to quantify. So, yung sample solution is, yun nga, piniplace siya doon sa cuvette, which is yung glass tube na nakita natin kanina. So, directly before the detector and after the dispersive device. So, yung cuvette, nagva-vary siya from test tube because it has uniform thickness and optical path. Yun, katulad ng sabi ko kanina, yung usually the cuvette is made up of glass or quartz. So, next one is yung ating output. It displays absorbance values for the user. So, ayan, doon sa balik tayo sa adjustable aperture. So, some spectrophotometers have adjustable apertures in order para makapture absorbance at different spatial parts ng ating sample. So, ginaguarantee niya that each sample reading directs at the same place in the sample, which eliminates error in uneven sample distributions. So, yung sample naman natin here, nagko-contain siya ng liquid solution which the user chooses to quantify. So, ang liquid solutions, minsan ano siya, dye, and the resulting absorbance values correspond to the amount of dye. Then, some spectrophotometers are able to quantify solid or gas mixtures but are much more expensive and use a different process. So, nagpa-quantify din, hindi lang liquid yung gina-quantify niya. Minsan nag-quantify din siya ng gas mixtures. Pero, pag ganun daw, mas mahal daw at saka iba yung proseso na nangyayari. So, next is ang ating output. So, yung output is displays absorbance values for the user. So, ito yung computer screen. Ito siya, oh. Ayan. Meron ako nakitang isang picture ng parts of spectrophotometer. Iba yung ano niya, yung itsura niya. Alam niyo yung parang sa may calculator gyud, yung parang digital na monitor niya, ganun yung itsura niya kapag real ano siya. So, it is a computer screen that has a separating operating system from the spectrophotometer, usually functions as the output device. Both the spectrophotometer and the computer internally connect, and the information output from the spectrophotometer saves directly on the computer. However, some spectrophotometers have an embedded screen on which the output displays. So, next tayo. Dito naman tayo sa why is the spectrophotometer important? So, with the use of such device, the person using a spectrophotometer can easily acquire spectra of shining white light on a given sample, thereby measuring the light that is returned from the sample. So the device is used in many different fields. One is the production facilities and yung isa is yung scientific laboratories. So the device is used in many different fields, especially in the production facilities and scientific laboratories. In a production facility, a spectrophotometer is used para ma-check yung quality ng products such as in clothing and emission of light during the manufacturing of LED light, to name a few. Ito naman sa analytical laboratories, which is kasali doon sa scientific laboratories, at a spectrophotometer is used para ma-identify for the identification and quantifying microscopic samples such as matching colors, kinetics, qualifying gems and minerals, determining the color of paint or ink, and so on. So, vital din siya. So, next tayo. Spectrophotometer calibration. So, ito, sobrang vital ito siya. So, it is a process by which the scientist or researcher uses a calibration standard to find out the light source's accuracy. So, vital siya para ma-make sure na yung device nag-function siya properly and para correct yung measurement, para ma-obtain yung correct measurement. So, the calibration technique varies according to the make and brand. So, the spectrophotometer is calibrated dito. Ito sa picture na to. It is calibrated using a potassium dichromate. Ayan. Ito siya. Ayun. So, ang spectrophotometer calibration, vital siya para ma-make sure na yung device is nag-function. Just like other devices, di ba, kina-calibrate natin siya bago natin siya gamitin. So, very important yun siya pag ganito yung mga ginagawa natin mga process.
So next is for the general principles. For the general principles of spectrophotometer, it is based on the Beer-Lambert law. So this law states that the absorbance of the solution has a linear relationship with the length of light and the concentration of a sample. So this is referring to the absorbance of the solution, connection to the length of light and the concentration of a sample, which is the amount of the light that is being absorbed. Also, standard spectrophotometer uses a cuvette of the length of 1 cm. So this cuvette referring to the small vial or glass that is used for the analysis with spectrophotometer. And remember, the length of the standard spectrophotometer is 1 cm. Going back to the Beer-Lambert law, it expresses as A directly proportional to CL, where A is the absorbance or the measurement of the light, C is the concentration of the sample or the amount of a known substance, and L is the path length or the distance the light travels through the sample. Or it can also be expressed as A is equals to the molar coefficient CL, same pa din, where A is the absorbance or the measurement of the light, C is the concentration of the sample or the amount of a known substance, L path length or the distance the light travels through the sample, and this symbol is the molar extinction coefficient, which is the value of which is constant for a specific molecule. Next is here is the principle or the formula for the spectrophotometer. So letter A is equals to negative log. So this negative log means transmittance light, or symbolizes as letter T. So this letter T is the transmittance light, which is the fraction of light passing through the sample. And this transmittance light expressed both transmitted light and incident light. Transmitted light is the amount of light passes completely through the sample, while the incident light can be reflected or transmitted through a sample. And remember that this incident light, it can be changes during interaction with other samples. So that's all for the short overview all about the principles or general principles of the spectrophotometer.
Next is the types of spectrophotometer. We only included the main types, which are the single beam and the double beam. The said types are included in the UV spectrophotometer. So, ang UV spectrophotometer is ginagamit para ma-measure ang material of adsorbance and quantitative analysis sa visible or ultraviolet light. The single beam spectrophotometer determines the intensity of the light reflected from this reference to measure the sample. By its name, single, gina-utilize niya ang one beam of light that passes through the sample and it travels in a single direction. Mainly, ginagamit siya for quantitative analysis. Suitable din siya for measuring absorbance or light transmittance. But ang reference cell is replaced by sample cell para ma-determine ang absorbance. Hindi siya suitable for high demanding pharmaceutical and quality inspection industries kay it is unstable. So kailangan sang stabilized voltage supply para ma-avoid ang errors due to changes in beam intensity. It operates between 325 nanometers to 1000 nanometers wavelength. Actually, itong single beam spectrophotometer na to is the earliest design of the spectrophotometer.
Single beam spectrophotometer is useful for measuring nucleic acids, purified proteins, and other organic molecules. With the help of this device, nagiging precise ang measurement ng nucleic acids, purified proteins, and other organic molecules. Application of single beam spectrophotometer. Determine color. Sa pag-determine ng color, gina-ensure na controlled ang light source para ma-determine if ang light nanggaling ba sa flame or sa light source. And the light source's intensity is being measured before versus after ma-insert ang test sample. Another application is determining the concentration of analyte in solution. For this part, ma-determine siya if ma-measure ang absorbance sa single wavelength, kag gina-apply man diri ang Beer-Lambert law and kinetic assays. Advantages of single beam spectrophotometer. Cost-effective. Single beam are less expensive as compared to other alternative. Better performance. Since single beam siya, wala nagasplit ang source beams niya and it has high energy resulting in high sensitivity of detection. Disadvantage. Instability. Nagiging unstable ang device and this happens due to lack of compensation for disturbances such as voltage fluctuations or drift in the energy of light sources.
How does single beam spectrophotometer works? So first of all, the light source, which is the deuterium lamp and the tungsten lamp, will be passed through the collimating convex lens. And then after that, it passed through the diaphragm. So ang purpose ng diaphragm is to ensure that there is 100% light that will pass through the monochromator. So, ano bang purpose ng monochromator? So, ang purpose ni is to produce a single spectral line from a multi-wavelength source. So, some part of the radiation is absorbed and the remaining is transmitted, which is passed through the focusing convex lens. That's the reason why one wavelength is only required to pass through the convex lens that will be then passed in the sample that is kept in the cuvette. And after that, the light will be then passed into the photocell. So the purpose of photocell is that it converts light energy into electrical energy. So the converted energy will be then measured in the galvanometer. So what is galvanometer? So this measures the electrical signals and displays it in digital form. So with this, dito mo malalaman yung representation ng absorbance of light based sa solution or sa sample na gi-analyze mo sa single beam spectrophotometer.
Next in line is the double beam spectrophotometer. It operates between 185 nanometers to 1000 nanometers wavelength using double beam of light. Since it has two photocells, the light beam coming from the light source splits into two beams. Yung isang beam, ginagamit siya for reference, and yung isa naman, it passes through the sample and it is used for sample reading. The double beam spectrophotometers can not only used for measuring high concentration samples and multi-component mixed samples, but ginagamit din sila for performing better in a turbid samples and giving accurate results for the samples. And it also provide more reproducible results kay they perform an automatic correction or recording for the loss of light intensity as the beam passes through the sample and the reference solution.
Application of double beam spectrophotometer: DNA analysis, wavelength scanning, protein analysis, kinetics, and quantitative analysis. DNA analysis is the process of determining DNA characteristics. Protein analysis, it is a technique for the detection, purification, and identification of proteins. So mainly, it is to identify a protein as well as characterization of its structures and function. Kinetics, kinetic in spectrophotometer offers an easy and less time-consuming analysis, and ginagamitan siya with simple reagents which are able to be used for routine determination of drug substances. Advantages of double beam spectrophotometer: more reliable detection. Ang double beam na device meron ng modern improvements, and meron na rin siyang high level of automation, which means it has a better level of detection compared to single beam systems. No warm-up time. For this device, hindi na kailangan ng warm-up time compared to single beams. This not only improves the result but also conserves lamp life. For disadvantage, double beam is expensive and it is difficult to use.
Since we already knew the application of double beam spectrophotometer, let us now understand and know the parts of it and how does it work. So the double beam spectrophotometer consists of deuterium lamp, tungsten lamp, gratings, selector mirror, reference or the standard sample, and the other detector, which is the PMT, or also known as the photomultiplier tube, wherein it detects even the smallest photoelectrons as it has internal amplification assembly. So even for the weakest light intensities, good amount of measurable photocurrent is generated by the PMT. So just like the single beam spectrophotometer, double beam spectrophotometer also need a light sources. So it needs a light source which gives the entire visible spectrum plus the near ultraviolet, so that you are covering the range from about 185 to 1000 nanometers. So we can get this range of wavelengths from a single lamp. Kaya nagkaroon ng double beam spectrophotometer, which is the combination of the deuterium lamp for the UV part of the spectrum and ang tungsten lamp, or also known as the halogen lamp, for the visible part. So the combined output of these two bulbs is focused on two diffraction grating. Now, the advantage of using double beam spectrophotometer is that the error due to intensity variations in source of light are eliminated. So, ang monochromic light is exiting the grating assembly travels into two different paths. One passes through a reference sample or the standard sample, and the other one passes through the analyte under the test, and both the solutions absorb part of light, falling on them and transmit the remaining light. So, ang transmitted light is picked up by the other detector, and readings are recorded, since the reference and sample under test are recorded simultaneously. So, any fluctuations in the light source are eliminated.